All right, seventh graders, today is day number 8 of our Dragster activity. I know we've spent more than 8 actual days in class working on this, but this is the final day where we're going to wrap everything up. And if you look here on your screen, the first thing that we're going to do is copy down some Dragster data. Because we didn't have these cars built in class and we weren't able to race them against each other and test them out on the track, we are going to give you some data that you can use to kind of analyze about how our cars actually work. And so I created 2 cars. I forgot them at school, so I don't have them here. But 2 cars that one was made out of wood. The other was the same shape and design except 3D printed. And I raced both of them and collected data for you. And so you're going to copy that data down today and do some analyzing. And we're going to analyze things by calculating the velocity and some different averages. And then you're going to respond to kind of that data in this project by answering some evaluating questions. And all of this is in the evaluating section of your design notebook. All right. Before we move on, there are a couple definitions that we need to be aware of. And those are velocity and speed and average. And this is going to be important when you analyze your information. So velocity and speed, this is distance divided by time. That's how it's calculated. You take the distance that something travels and you divide by the amount of time that it takes, because that's what speed and velocity are the relationship between those 2 factors, distance and time. For this project, we are calculating the distance that our car goes in inches, and the time that we're using to measure is seconds. So we will take, to figure out velocity, the total number of inches that a car goes, and divide that by the number of seconds. Okay? Average, as you should remember from math class, is the sum of all numbers divided by the total numbers that you added together. So as an example, if I have some data, and I collect data, 13, 16, 18, 11, and 20. Whatever that is, it doesn't matter. But I collect those numbers, and I want to figure out what the average of those numbers are. First, I would add them together, 13 plus 16 plus 18 plus 11 plus 20, and I get a total of 78. I then need to divide by 5 because I have 5 numbers that I had added together. So 78 divided by 5 is 16.5, which would be the average for that data set. Okay, this would be a great time to do 2 things. One, write down these definitions so you have them as you're working on analyzing the data that we're going to give you. And the second thing is to open up your design notebook. So go ahead and do that right now. All right, we should now have our design notebook open. So once again, today is day number 8. And so we are not able to race our cars right now because we are in distance learning. But we are going to complete some velocity data, and then we are going to answer evaluating questions and our essential questions. So as I scroll down here through my design notebook, let's start with our essential questions. Now the first thing that we want to do is we actually want to take out a couple of these questions. So this question here, what do the markings on a ruler represent? I'm going to just highlight this, and one thing that you can do is if you go up to Format, choose the text tool, we can just strike through this, which just crosses off that question. Same thing with this next question, what is the purpose of sanding our dragster? You don't need to answer this question. Now if you went ahead and you had already answered this question, that's great, just leave it in there. But since we didn't actually make these dragsters out of wood, we don't need to answer that question. All right, we can answer all of the other essential questions though, and that's something that you need to do today. All right, if you want to pause this video and answer those questions now, go ahead and do that, or you can come back to this. All right, now we are going to scroll all the way down to the end of our design notebook to evaluating. So we have some data that we want to give you from 2 different cars. So one of the cars that I built was out of wood, and so label this, it says data dragster number 1. You can just type wood in right here after this one to show that this is the information from the wooden dragster. And then we want you to copy this data down right here. I tested this out 5 times on our track in class. So the mass was 50.40 grams. That didn't change. I didn't make any changes to the car in between the first time I tried this and the second time that I tested this out. So all of these masses are the same. Same with distance. The track that we have in class is actually 270 inches long. And so the car, when I tested this out, actually made it to the end of the track all 5 times. The times were 1.09 seconds. The second was 0.96 seconds, and 0.88 seconds, 1.12 seconds, and 0.92 seconds. So go ahead and copy in that data in your notebook right now. Go ahead and pause the video. Now that you have this data entered into your design notebook, you are going to calculate the velocity for those 5 trials. Okay? Remember, velocity is distance divided by time. So you're going to take 270, you're going to divide it by 1.09, and that will tell you the velocity. Now, this is a difficult math problem to do, so I would suggest you use a calculator. You've got calculators on your Chromebook, you have calculators on your phones, and a lot of you just have calculators as well, like real calculators. So go ahead and type in 270 divided by 1.09. When I do that, I'm just using my phone calculator, I get 247 and then a whole bunch of decimals. I'm just going to round to the 10th place. 1 digit after the decimal is fine. Actually, let's go 2. So it's 247.71, and now we are measuring velocity in inches per second. So that is the velocity for the first trial. Go ahead and calculate the velocity for the other 4. Pause the video and do that right now. Your next step is to calculate the average for these different columns. So if you recall, our definition of average is to find the sum of all of our data. So we're going to add all of the masses together, and then we're going to divide by, in this case, 5, because I have 5 numbers that I'm adding together. So 50.4 plus 50.4 plus 50.4 plus 50.4 plus 50.4. Once you get a sum, a total, then you're going to divide by 5. Fill that in this column. The second column right here, this should be your average distance. Third column is the average time, so add all these together, divide by 5. And then the last column here, your average velocity, would be all of the velocities that you just calculated, divided by 5 will tell you your average. So go ahead and pause the video now and calculate those averages. Now that you have your averages calculated for the wooden dragster, we are going to scroll down to the second chart, and this one was data from the plastic dragster that I created and 3D printed. So we're going to do the same thing. So you can see that this dragster was raced, or it was tested 5 different times. I've got the mass because I didn't make any changes to it, so the mass stayed the same for all of these. The distance, this car also went to the end of the track, so our distance was all the same, 270 inches, but the times were a little bit different. So again, calculating velocity, this is distance divided by time, so I'm going to, on my calculator, do 270 divided by 1.16, and when I do that on the calculator, I get 232.76, and again, our velocity, because we're measuring using inches and seconds, is inches per second. So the velocity of the first plastic dragster run was 232.76 inches per second. So go ahead and do the same thing that you did in the chart above. Calculate all of the velocities for the 5 trials for the plastic dragster, and then calculate the averages. So go ahead and pause this video and calculate those now. Now that you have your data charts filled out, the last thing that needs to be completed for our dragster project is to answer these evaluating questions. Notice for a lot of these questions, there's parts that are in blue. These are parts of the question that you must answer, and there are parts of the questions that are in orange. Those are things that you should answer. And if you look down at number 3, this one is a part of this question is in pink. So that's, again, an aspire to do. So make sure that you are all answering the must answer parts of the questions, the parts that are in blue. You should be answering the parts that are in orange, and you can aspire to answer what's in pink. There are a couple questions, because we weren't able to test these out in class, there are a couple questions that we will cross off, but we'll get to those as we kind of go through here. So question number 1, what did you find the most difficult about this project and why? Again, pay attention to the must do and the should do. Question number 2, during the Dragster activities, you experienced the creative process of taking an idea from the design stage to building a working prototype. Prototype is just a model of something that works. What is the most important lesson that you learned while working on this activity that you will use on future projects? It's a must-answer question. Question number 3, identify forces other than the compressed air acting on your dragster. List 2 to 4 forces and make reference to where they affect your dragster. Okay, what we're going to do is we're just going to, because you didn't race your car, I'm going to cross off that part of that question. But you still should be able to answer what other forces, other than the air that pushes the car down the track, what are other forces that act on your dragster or act on a car as it drives up along the road. You should have reference to some of this from your research that you did way back at the beginning of this project. Question number 4, we didn't do this question, or we can't answer this question because we weren't in class. So we can cross that one off. Question number 5, this goes back to the data that we just analyzed up here in the charts. Is there a relationship between mass and average velocity for the results? When you look at that, when you look at the average mass and the average velocity, is there a relationship? Does more mass make a car faster? Does more mass make a car slower? Look at your data to answer that question. You should answer that question. And then explain why there is or isn't a relationship. Question number 5. This is a question that we need to cross off because we didn't have a chance to race our cars in class, so you couldn't compare your dragster to your classmates. Question number 7. What changes would you incorporate into your design to improve your performance if you could redesign your dragster? I know you didn't race it, but if you could go back and you could start this again, what would you do differently when you were designing your car? All right? Make sure your summaries and everything are done as well. You should have a final summary for today as well. But get this done. Again, we want to make sure that we have everything complete, and that includes copying that dragster data, calculating your velocity and averages, and then responding to those evaluating questions in your notebook. Please reach out to your teacher if you have any questions, and good luck with finishing up this project. We will be moving on next time in class to a new project. Have a great day.